Today we're going to be learning about metamorphic rocks. This is going to be one of our handwritten sets of notes where we have kind of bubbles and lines, and as usual I have my paper turned landscape because that's the way my board goes. So you can orient yours however you like. We're going to start approximately top center with our title, which of course is going to be Metamorphic Rocks. We're also going to put a short definition here. And metamorphic rocks, as we learned in our other notes, are those that have been changed by heat and pressure to make a new rock. There are two categories for metamorphic rocks, and they come from the type of metamorphism that causes them. There are two different ways that metamorphism can occur. The first is called contact metamorphism. And as you might expect, this occurs when you have contact between magma and the rock. So the magma has to be in contact with the rock. This kind of metamorphism produces rocks that we call non-foliated. This word comes from the word foliage, like leaves. So when we talk about non-foliated rocks, those are the kind that do not have layers. So no stripes, no bands, no layers. There are three non-foliated rocks that you'll see in your lab. First we have marble. Marble comes from limestone. We should remember that limestone reacts with acid, so marble also reacts with acid. And one other thing we should know about it is that it's used for building purposes. Tiles, floors and countertops. Marble is a very popular choice for that. It also used to be used as headstones or gravestones. It's not used so much anymore because it reacts to acid, and that makes it susceptible to chemical weathering. The next one that you'll see in your lab is called quartzite. Quartzite comes from quartz sandstone, and it comes in a variety of colors. The third one that you'll see is a type of coal. With the sedimentary rocks, we learned that there are three types of coal, and this is the second one that we'll see. It's called anthracite coal. Anthracite, as you might be able to guess, comes from bituminous coal, which is the other kind that we saw with our sedimentary lab. one thing that you might want to note about the appearance of anthracite makes it a little bit different than bituminous is that it is shiny. And of course, as you would expect coal to be, it is still black. The other kind of metamorphism is called regional metamorphism. And we'll abbreviate there because we're running out of space. Regional metamorphism is where you have large areas that are exposed to extreme temperatures and pressures. This might be from the movement of Earth's tectonic plates, which we'll talk about in the next chapter. Regional metamorphism is going to cover a much larger area than contact metamorphism. So large areas of extreme pressure and temperature. And this kind of metamorphism produces rocks that are foliated. And those are the ones that have layers or bands or stripes. They have layers or stripes because of the way the pressure pushes on the rocks, and it tends to line up the minerals that are alike, so you end up with stripes or bands of different colors. Not always, but frequently. One of those banded rocks that you will see in your lab, and we'll just put right here next to the arrow, this is a banded or a striped rock, is called gneiss. And gneiss comes from granite, which might make it somewhat easy to recognize because it will look very similar to granite if you remember what that looks like from your igneous lab. The next one that you'll see is a rock that has cleavage. It's got flat surfaces and it's very shiny or very sparkly. And that is called schist, which comes from a combination of things. Shale being one of them, that was one of our sedimentary rocks. It also comes from mica, which was a mineral that we looked at, and sometimes includes garnets in it, which is another mineral. And then we've got one more on the foliated side. That one also has cleavage, meaning it has flat surfaces that break easily. And that one is slate. Slate comes from shale. And it is also used for building purposes. Things like tiles, even things like chalkboards, and the base for pool tables are typically made of slate. Hopefully this will help you recognize your rocks in your lab tomorrow.